everybody. This video is going to be talking about solving systems using what we call Cramers Rule. Basically, we're using the determinants to solve these systems, right? And what we basically do is we make three matrices using the coefficients and constants within the system. Okay, so if you look here, our first matrix, right, is being made up of the coefficients of the x's and the y's. So you can see A1, B1, A2, B2. Then what we're going to do is, if you look here, our constants, right, are going to replace either the x's or the y's. If we replace the constants with the coefficients of x, then we basically keep the coefficients of y's here. Then we basically kick out the coefficients of y, and we replace them with the constants, and then we keep the coefficients of x here. What we're going to do is find the determinant of each of these matrices and use them to find the solutions to the system, right? Once we find the determinant of x, we divide it by the coefficient, matrix, the determinant of that. Then d of y divided by d. When we take these determinants and divide them, it would give us the value of x and the value of y. So let's take a look at this. So first thing we're going to do is we're going to create our first matrix. So we're going to say D is the determinant of, we're going to take the coefficients of x, you got 3 and 4, and the coefficients of y, 5 and -1. We're going to go ahead, we're going to evaluate the determinant of this. So the determinant would be -3 minus 20, which is -23. Then, what we're going to do is find d of x, the determinant of the x, right, which is going to be, we're going to replace the coefficients of x with the constants. So 7, -6, now we're going to keep the coefficients of y here. We're going to find the determinant of this. The determinant of this matrix would be 7 times -1 is -7 minus -30. That's going to end up being -7 plus 30, which is 23. Now we're going to find the determinant of y. So now we keep the coefficients of x, 3 and 4, but now we're going to replace the coefficients of y with the constants, 7, -6, and we're going to find the determinant of this. So that would be -18 minus 28, which gives us -46. Now, once I have the determinant of each of these matrices, right, I'm going to find the x value by taking d of x and dividing it by d. D of x we said was 23, divided by d was -23, which would give us -1. The y value would be d of y divided by d. D of y is -46 divided by 23 is -2. So the ordered pair solution to this system would be -1, -2. So to quickly solve the next one, we're going to make our coefficient matrix, right? So we're going to say D, the determinant of it would be, you have 2, -5, 4, -2. The determinant of this would be -4 minus, it's going to give us -20, which is -4 plus 20, which is 16. So d of x, now we're going to replace the coefficients of x with the constant. So we'd have -2, 13, right? Then the other one would be 4, -2. And now we're going to find the determinant of this. That would be 4 minus, it's going to be 52. 4 minus 52 would be -48. D of y, keep the coefficients of x, so 2, -5, but then the constants will replace the coefficients of y, negative 2, 13, and that would give us 26 minus 10, which is 16. So the x-coordinate for the solution then would just be, again, d of x over d, which would be negative 48 over 16, which is negative 3. Y would be d of y over d, which would give us 16 over 16, which is 1. So the ordered pair solution would be negative 3, 1. Okay, now 3 by 3s are no different, right? You're going to do the same exact thing, right? And I'm not going to go through all the coefficients. You know, coefficients of the x's will be your first column. Coefficients of y will be your second column. Coefficients of z would be your third column. And then we would use these constants to replace the x coefficients, the y coefficients, and the z coefficients. And then we would do the same thing we did for the 2 by 2 systems. Let's look at the first example here. So what we're going to do first, right, is we're going to find the determinant of the coefficient matrix. So D equals the determinant of, we're going to do 3, 2, 1. That's a coefficient of the x's. Negative 2, 3, negative 4, then negative 1, negative 2, 1. We're going to go ahead and find the determinant of this. Remember, this is a long process, okay? So to do this, take the first term, 3, multiply it by the determinant of 3, negative 2, negative 4, 1. We're going to subtract the determinant of 2 times the determinant of negative 2, negative 1, negative 4, 1. Then we're going to add the determinant of 1 times the determinant of negative 2, negative 1, 3, negative 2. So remember, this is going to be, if we basically find the determinant of this, we get 3 minus negative 4 times negative 2 is 8. So it's 3 times negative 5. Then negative 2 times the determinant of this would be negative 2 minus 4, which is negative 6. And then plus 1 times, it's going to give you 4 minus negative 3, which is 4 plus 3, which is 7. And now, negative 15 plus 12 plus 7 is going to give me 4. So now next, we're going to duplicate the same problem, but now we're going to replace the x coefficients with the constants. So now we're going to say d of x is equal to, replace the x's with the constants. So negative 6, 1, negative 3, then negative 2, 3, negative 4, then negative 1, negative 2, 1. And now we're going to go ahead and find the determinant of, so the determinant of this, we're going to go negative 6 times the determinant of 3, negative 2, negative 4, 1, minus 1 times the determinant of negative 2, negative 1, negative 4, 1, plus negative 3 times the determinant of, what's this going to give us? We're going to have negative 2, negative 1, 3, negative 2. So now, negative 6 times the determinant here would be 3 minus 8 again, which is negative 5, minus 1 times, that's going to give us negative 2 minus 4, which is negative 6, plus negative 3 times, it's going to give us 4 minus negative 3, so that's 7. So the determinant of this would be 30 plus 6 minus 21, which would give us 15. And we're going to duplicate this process for d of y. I'm going to pause the video and go through the work, right, and explain it so it doesn't take as much time. So if you pause the video and kind of take the notes, right, as you can see what I did here is for d of y, I took the y coefficient out and replaced it with the constants. Then here I found the determinant, right, of that matrix, okay? And here's all the work for that. Okay, then I duplicated the process. And again, you can pause this at any time and rewind it. But what I did now is I took the z coefficients out and replaced it with the constants, right? And then again, I found the determinant of this matrix. Here's all the work for that. Okay, that should be the easy part because we've done determinants prior to the lesson. So now, as you can see, we found d is 4. We found d of x is 15. Found d of y is 16. We found d of z is 37. So now to find the x coordinate, we do the same thing. D of x over d would give us 15 over 4. Leave it like that. Leave it in fraction form. To find y, we're going to take d of y divided by d, which is 16 divided by d, excuse me, which is 4. And then z would be d of z divided by d, which would give you, what is that, 37 over 4, and leave it like that. So our ordered triple or solution for this system would be 15/4, 4, and 37 over 4. It's a lot of work, right? And there's a lot of room for mistakes. So make sure, right, you are very detailed with your operations. Now, I'm not going to go through this last one. I just want to set up your first matrix for you, right? And then you guys can go and I'll give you the solution and you can go and kind of practice using this one. But with this, your D would end up being the coefficients of x. You have 3, you have 4, but this bottom matrix or equation does not have an x. So we would say it's 0, right? Because that'd be 0x plus 6y. Now, your y coefficients would be, start with -5 up top, then you have 2, and then you have 6 here. Then z's, you have -4. You don't have a z in the middle one, so we're going to put a 0, and then -4 again. Then we would go ahead and find the determinants of these matrices. Okay, so you would take that and go through the same process from up above. And when you do that, you should get your ordered triple solution to be. So the solution you should get is going to be 1/2, -1/2, and then 2. And what I did here is I set up all of your matrices and I found the determinants for them, right? And once you know these determinants, you know x is going to equal d of x, -100 over -200, which you should know is the same as 1/2. Y is going to be 100 over -200, which is -1/2. And z would be -400 over -200, which is 2. So your ordered pair triple would be ordered triple 1/2, -1/2, and 2. Okay, go ahead, try the homework, and let me know if you have any questions.